right, so today should be a pretty straightforward lesson. We're actually just basically reviewing concepts that we've seen before. And the whole point of this is so we have the ability to apply them to new things, new applications of them. So nothing too new. The first thing we're going to be looking at is something called scope. Now we talked about this before and what it actually means. Today we're going to revisit the idea of variable scope and accessibility. Basically, where and when does a variable exist? What does that actually mean? Well, first of all, you need to remember what the two, recall the two things that comprise the properties of a variable. How long is it in memory? So when it's first defined, how long does it last in the RAM? All right. Now, of course, that also refers to our C# dictionary, which we talked about before, all those key words. When we define a new variable, it gets added to that dictionary for however long it exists in memory. The second part of this is where in the program the variable is usable. Where can we actually access the data of that variable? Or if I try to use it outside of that area, where will it give me an error? So those are our main concepts. Now, in order to do this, we need to remember that we've always created our variables in one of two places. The first place we created them was globally. We call these global variables, and these are variables that are defined outside of the main and just inside the class line. So what I mean by that is we create our global variables right up in here. So these are global variables. And what we have to remember about global variables is that when we create a global variable, we have to state the fact that it's static. So we might say something like static int user age. I don't have to give it a value at that point. We also have to remember that any any constant we create also needs to be global variables. It doesn't have to be, but it's a pretty common practice to make sure that that's actually the way it works. So going back to our little presentation here. So global are variables that are defined outside of the main method and just below the class line. We just squeeze it in there, right? So these variables are in memory for the entire life of the program. Now, let's look at that code one more time just to see this. So I define this variable inside of the class. Another way to look at that is this variable exists both in memory and is accessible anywhere between this bracket and this bracket, the opening bracket and the closing bracket of that class. So that means anything in between there, I can use this variable. It's completely accessible. Well, that brings us up to the idea of this is just another mention of the static keyword, but that brings us into the local idea. So local variable is a variable that is defined inside and at the top of a method, such as main. So what do I mean by that? So a local variable for the main method would be created right inside of here. So I might have string user age. This is a local variable that's defined inside of this main method. Now it, just like the global variable, exists in memory for as long as these brackets are still going, right? So as long as we're between these two, or as long as the execution is between those two brackets, string user age exists both in the C# dictionary as well as in our RAM. Now I can use user age in here. I can do something like user age is equal to 10 there, and that's not a problem because this is a global variable that's accessible everywhere in the program. Now, at some point over the next couple of days, we're going to be creating our own methods, kind of like main. I don't know why it's not selecting things right here, and we're going to be creating them down here. I'm not going to go into detail, but they're going to have their own set of brackets, and we can create variables inside of here as well. So, I don't know, string word. Now, the thing is, I'm not going to go into the detail here, so a method. Anything that's created inside of these brackets is only usable inside of these brackets. Same with these ones up here. So I cannot use user age down in here. If I tried to use user age inside of this set of brackets, oops, not user age. User age would be fine. That should be user name. Getting everybody confused. String user name. So user name, if I try to set this to Bob, for example, not BPB, to Bob, this would actually fail because according to the C# dictionary, this wasn't defined within these brackets, so it doesn't exist. We get an error message here saying, I can't find this word, I don't know what you're talking about, right? The same thing goes up here. I wouldn't be able to do anything with word up in here. I wouldn't be able to say word, dog. can't do that because word is not a variable that exists inside of this set of brackets. User age exists everywhere because it's inside of the outer brackets. But these guys are created locally inside of their own set of brackets. So that does not actually work. The same thing happens if you try to define a variable inside of an if statement. You're going to run into a whole bunch of problems. That's why we typically define our variables outside of if statements. And secondly, we also try to define our variables always at the top of the block of code that we're currently in. Right? So you see I'm way up at the top here of my main method. So try to create it at the top. You don't want to have a whole bunch of logic and then create another variable down here somewhere. That's no good. So remember, we always want to try and keep our programs organized, and one of those organization techniques is to always try and define our variables at the top of our block of code, in this case, the top of the main method. Just like outside, we try to create our variables at the top of our class. Okay, let me get rid of this because that's actually broken because we haven't learned that part yet. We'll come back to it though. So, local variables, a variable that is defined inside and at the top of a method, such as main. These variables are in memory until the closing curly bracket is reached by the logic, at which point it is deleted. It's actually kicked out of memory. It doesn't exist there anymore. It's also kicked out of the C# dictionary. It doesn't exist there as well. This actually frees up the memory for other data and other programs. So not only does that free the memory for our program, but it actually frees it up for any program that's currently running on the computer. This is important for obviously for memory management, and it allows your computer to keep running faster and faster and faster. So if you have 7 programs running at the same time and they're all using a certain amount of memory up, well, that makes it harder for more programs to get access to that memory. So you want to free up that memory whenever possible. It keeps the whole computer running smoothly. Finally, these variables are only usable inside the set of curly brackets that they were defined in, as I already stated. So we have two levels of scope, global and local. So when do you use which? Well, we've briefly touched on this before when we first started talking about variables, but let's go through a little table. So for global variables, the big pro is that you can use the variable anywhere in the program. And this is a really big pro, especially for new programmers, because it makes it easy for them. They know that they've defined it. They don't have to worry about it anymore. It's great. It's good to go. The con of global variables is that it consumes memory for the entire life of a program. Our programs are not just a matter of solving a problem. It's solving a problem well. We always want our programs to be efficient as possible. And efficient means 2 things. It means it saves memory and it saves speed. So in this case, CPU. So time and space. Okay, that's what we're looking at. So let's jump over to local variables. The big pro for local variables, the used memory is deleted and freed up at the end of the method or the code block. Just completely, it's gone. We don't have to worry about it anymore. And that frees it up for a whole bunch of other things. The big con of this, you can only use the variable inside the method that it was defined in. Now I keep using this word method. So let's talk about what that means. Oh, I'm getting past that. I'm getting past myself here. There we go. So the term method refers to a named block of code that has its own logic surrounded by curly brackets. We've seen the main method. This is a method. We've also seen other methods as well. We just didn't see how the code works. So things like math.pow. Pow is a method. Square root, the squirt, is a method. Write line, read line, these are all methods. Basically, it's a grouping of logic. That's all it really is. It's a grouping of logic that has a name associated with it. In the main method's case, the name of it is main. So a method just refers to a grouping of logic, actions, functionality, that kind of thing. Now, I've referred to it also as code block throughout this course, and that's just to try and keep it simplified. It's a block of code. Well, it's a block of code that has a purpose. And many languages refer to these things as methods. We're going to come back to this more later on, though. So before I jumped ahead of myself here, got all my things out of order here. So what's the answer already? When do we actually use which? Ideally, everything you create is a local variable. Everything. But there are some things that benefit greatly from being global. Now, I'll give you an example. When making some games, the data needs to be accessible everywhere, right? And as many methods as possible. So for example, score. Score, if you think of a game like Super Mario Brothers, the score is displayed on the screen. The score is updated every single time that you touch a bad guy, every time you pick up an item. At the end of the level, when you get all your bonus points, things like that, there's high scores. So score is used everywhere in the program. So it makes sense to make that variable global, not just some local variable, because it's going to be used everywhere. All right, so you're going to ideally try to make everything local, but sometimes there are situations where it just makes more sense to make it global when you need it all the time. Okay? All right. So now that we have covered scope, let's go back to another term that we've referred to before as well, parameters. Now, parameters, if you recall, are basically, well, let's not get ahead of myself here. What is our objective here? Our objective is to understand the what, the how, and the why of passing data into a method. Well, that's where the term parameter really comes into play. What do I mean by that? A parameter is the storage variable for the data given to a method inside the round brackets when we call it. So you've seen, for example, math.pow. The 2 and the 3 there, those are parameters. Those are values that we're storing in temporary variables. So 2 and 3 are values that will be stored in temporary variables. Those temporary variables are the parameters. The 2 and the 3 aren't the parameters. They're stored in the parameters. Okay, a parameter is just a fancy name for a variable that a method uses to do its job. Okay, it's data that's required for the method to do its job. Pow, which calculates the exponent of a number. It can't do its job unless it has both a base and an exponent given to it. Console.writeLine. WriteLine cannot do its job unless we supply it with text to actually write. So those are parameters. The text in WriteLine, the base and the exponent of pow, just those are the parameters. Okay. Now, we're going to really need these going forward because we have to be able to specify our own. We're going to go into a little bit more detail on this. A parameter is a local, temporary variable that stores a copy of the data given to it when the method is called to be executed. A copy, there's the big key there. Temporary, another big key there. So temporary tells me that it goes away, and it does. As soon as the WriteLine command is done, that message that I passed into it is deleted. It's gone. It doesn't exist anymore. But you might say, but what if I gave it a variable? What if I said console.writeLine username? It doesn't delete my username variable. No, it doesn't. And that's where that word copy comes from. It's a copy of the value. It's not the actual value itself. Okay? So it's going to go into your username variable, pull out the value of username, and it's going to copy it, and then it's going to take the copy and give that to WriteLine. So then WriteLine is going to use it for all of its magic, and then it's going to delete the copy. The original username variable is completely left unharmed. Just like when we did string manipulation. We took the data, we manipulated a copy of it, and got a new string in return. We didn't actually change the original data. The same thing happens here. The parameters are getting copies of our data only. So, we're going to focus on WriteLine here because it does a great job of exemplifying this. WriteLine is a method that has one parameter of type string. We could give it a literal value like hello world, or we could actually give it another variable, in which case it does exactly what I tell you, what I just said it would do. In both cases, a copy of the value is stored in WriteLine's message variable. Now, it has its own variable there. So that string message, that is the parameter for WriteLine. And the value we pass in gets copied into that variable. So message is going to hold the value hello world, for example, during that previous bullet point there. Okay? So parameter just holds a copy. Go on. Of course, go on. A parameter is a piece of data required by the method for it to do its job. Again, it can't do anything unless we tell it what it needs to do. WriteLine POW will not be able to do their task without the data passed in. So do all methods need parameters? Well, have we used any methods in this class that do not require something inside those brackets? Yep, we have. ReadLine. Console.readLine does a task, but it doesn't need any help to do that. So it doesn't actually have any parameters. but we still have to write the brackets there. Just because they're empty doesn't mean they're not needed. So console.readLine is an example of a method that doesn't require any parameters. It doesn't require any data to do its job. It can do its job all on its own. Now we're going to create our own methods. And sometimes we're going to have parameters associated with it, but other times we're going to be able to go on without them and say, nope, I don't need it. I'm just going to do the task and it's good to go. All right. So what if? What if you call a method but do not give it the needed data? So let's say we say console.writeLine, but we forgot to give it a message. Well, that's a problem. The program won't even compile. It'll actually be a syntax error because it's expecting that, right? It's like if somebody says to you, if the teacher says to you, do your homework, but they don't tell you what actual questions to do. You can't physically do it. You sit there spinning your wheels. So this obviously is not an ideal situation. So that's something we got to avoid. What if the data given is okay? You actually gave it data, but it's in the wrong order or the wrong type. Well, let's think about that for a second. Well, wrong order. Let's think of math.pow for a second. With math.pow, if I put in 2, 3, so a base of 2 and an exponent of 3, I get a value of 8. But what if I accidentally swap those numbers and I put 3, 2? Well, that's a completely different answer. That's 3 squared, which is 9. That's a completely different answer. So putting things in the wrong order won't crash our program, but they will give us unexpected and sometimes unwanted values, sometimes unwanted results. So swapping values, not necessarily a problem if they're the same type. But what if they're the wrong type? What if one is an int and one is a double, for example? Well, that's a completely different issue. Because it's going to take your, let's say it's expecting a double followed by a string. And you accidentally swap them, and so you supplied a string first and then a double. It's going to try and take your string and store it into its double parameter. Well, you've all made that error before in your own programs when you were doing your conversion and reading data from the user. You'd read a string in, you'd try and store it in your integer variable, and you'd be like, oh, that did not work. It tells me that I'm trying to stuff something in that I can't fit. Square peg, round hole. So if you put in the wrong type, chances are the program will either, depending on when that data was actually supplied and how, it usually will give you a syntax error as well. It won't compile, but sometimes it'll actually crash while the program is running, depending on the structure of the code and how you've actually built that. Right? So, oops, I went over here. Ah, wrong way. It's not going here. There we go. I don't know what's going on here. So, however, if the swap values were of different types, like a string and an int, the program will most likely not compile because you're trying to stick a square peg in a round hole. You can't make it fit. There are some exceptions to this rule. The big exception is this. If you try and take a smaller number type and put it in a bigger number type, it'll work just fine. So if I try and put an integer inside of a double parameter, no problem. If I try and put a byte inside of an integer or a double, no problem. If I try and put a double inside of an integer, big problem. You're trying to go from 64 bits to 32 bits. Doesn't work. Square peg, round hole. You can't physically fit it. It's like trying to drive that semi-truck into your garage. It's not going to work. So you got to be conscious of what you're doing with your parameters. So, final conclusion on this. When a method requests data for a parameter, it's just like a contract between the programmer and the method. Basically what that means, the method promises to do its task perfectly. Console.writeLine says, I am going to do my job as long as you give me my text. But only if you give me my text. If you fail to do that, I refuse. I won't do it. In fact, I'll complain. I'm saying I'm not even going to compile. And that's exactly what happens. I don't know what's going on with my computer here. So, remember that the data given to the parameter when the method is called is a copy of the data. It's a copy of the original data. So if the method changes the parameter's value, the original data remains unchanged. What do I mean by that? So let's say, for example, you had a program, a method. Maybe it was math.pow or something like that. It doesn't really matter. Maybe it was math.pow. And inside of there, it changed the value of that base variable. Well, it's not going to change anything outside of that subprogram or anything outside of that method because it's a copy of the data. It's its own variable. Anything outside is completely forgotten and doesn't even know that it exists at this point. Okay? So inside the method, it's all on its own. It's playing with copies of data, so anything outside remains unchanged and safe. So that's it for this lesson. All we talked about was scope and parameters. Scope basically says, where can I use my variables based on where they're defined. Parameters are simply the temporary variables that are part of a method that are required for that method to do its job. That's it. That's the TLDR of the lesson.